Based on free inertial technology, the Gipsea metrology system enables the accurate measurement of relative positions and depths between underwater structures, as well as their full orientations, in a single ROV dive. Gipsea's self-contained underwater component, or subsea bottle, incorporates an inertial measurement unit. Using an ROV to transfer the bottle between subsea structures a set number of times, the system can calculate a 3D position within an accuracy of 5 centimeters or less for baselines of up to 50 meters. This is achievable within just a few hours. By contrast, traditional acoustic metrologies can take over a day to carry out, with transponder arrays to install and repeated dives to extract readings from individual sensors. The Ipoz Gipsea free inertial metrology system is available exclusively from Fugro via its global network of survey companies. Fugro has conducted extensive trials in realistic environments to test Gipsea's equipment, software and support services. This video follows a validation trial and demonstrates how the free inertial metrology process works. The first stage of the trial involved setting up equipment that would mimic the subsea infrastructure. This consisted of 2 purpose-built tripod frames, each equipped with a typical fully operational metrology receptacle. Positioned along the dry dock centerline, 30 meters apart, the tripods were weighed down using 3 500-kilogram blocks. A dimensional control survey was then performed to determine the 3D relative position between the metrology receptacles. This was carried out using a high-accuracy reflectorless total station on the dry dock quay. A control network was created to repeat the dimensional control survey and confirm that the tripods did not move during the trials. Fugro StarPack GNSS receivers were used to simultaneously log data from 2 antennae positioned 40 meters apart. This enabled a known baseline to be created, with a precise static baseline solution being calculated in post-processing. The dry dock was then flooded and the ROV readied for deployment. A 3,000-metre depth-rated CI Jaguar ROV was used in this particular trial. It was deployed via an umbilical winch and A-frame launch and recovery system. The Gipsea bottle is held by the ROV's grabber arm during deployment. The bottom of the bottle is equipped with an interface stab designed to fit into the receptacles located on the subsea infrastructure. The system is interfaced to the ROV via a 5-metre whip, providing power and communication. The ROV and its tether management system were launched into the flooded dock. Once in position, the ROV flies out of its TMS cage towards the base point and places the bottle in the receptacle using its manipulator. The ROV pilot and the navigator operating its manipulator are in a control cabin on the quayside. The ROV's cameras are positioned to ensure a good view of all equipment used in the metrology operation. The surveyor uses dedicated Gipsea software to power on the bottle and initiate a 1-hour static alignment process. During this process, the ROV's manipulator rotates the bottle through 360 degrees in 90-degree steps. The surveyor initializes the metrology loop in the Gipsea surface software by taking a position fix at the base point. The base and target point locations, along with the real-time Gipsea position, are displayed on the ROV pilot's screen. The ROV now picks up the Gipsea bottle and flies to the target point, the other tripod and receptacle in our trial. The bottle is stabbed into the receptacle and left static for 1 minute, whilst the inertial navigation system processes zero velocity or ZUPT aiding. A position fix on the target point is then taken using the Gipsea surface software. The ROV then transfers the bottle back to the base point receptacle, where it is again left static for a minute while processing ZUPT aiding. The surveyor closes the metrology loop in the Gipsea surface software by taking a second position fix at the base point. The metrology loop is repeated a minimum of 10 times, with the surveyor checking results on the fly and discarding inconsistent data. Satisfied that loop data is acceptable, a full metrology field report can be generated instantly. The ROV picks up the Gipsea unit in its grabber arm and flies back to the TMS for recovery to the surface. Despite poor visibility, the validation trial proved successful. Based on 10 loops, the trial results concurred with the dimensional control results taken prior to and after the trial. The horizontal and vertical distances were found to agree within 5 centimetres, whilst the baseline heading agreed to within 0.1 degrees. These discrepancies are well within metrology tolerances. Lessons learned from the Gipsea metrology trials are incorporated into the design of smart mechanical interfaces that facilitate faster, easier docking into common and more challenging metrology receptacles. Fugro and Ipoz have developed the Gipsea equipment and associated software using experience and results gained from various trials. This is in line with our commitment to continually enhance customer service. Conducted in a single ROV dive, the Ipoz Gipsea free inertial metrology method dramatically reduces the duration of subsea surveys and the presentation of results. The Gipsea method can be used even with no acoustic line of sight between receptacles. The process is also immune to acoustic interference caused by water injection or drilling. The simple methodology reduces the opportunity for error and speeds up operations. Fewer personnel and less equipment is required to conduct the surveys, achieving the same degree of accuracy in a fraction of the time. Gipsea free inertial metrology. The future of subsea metrology. Available right now.